So today we're going to actually finish chapter 6, and we're going to throw another section in. That's the section 8.4 that used to be in 6, and then the author moved it to 8, and I, of course, disagree with that. I think it should still be in 6. So we're going to do 8.4 after we do 6.4, and then we have two more quick sections to cover that conceptually you know how to do. I just need to point out that you can do it for anything. And you'll see what I'm talking about in a minute. Last class, we started with this thing called a constructor. Okay. And, here's the verbiage. When I use a constructor, it's when I'm instantiating an object, right? I'm creating a variable that's a type of a class. Okay. It sort of looks a little bit like methods. It's going to be after the fields, but it's going to be before the methods. The constructor always has the same name as the class, and it helps us store initial values. And actually, we don't teach it this way. Some work can be done there. And I go grade AP, high school AP test, and some students, when they're writing their constructors, they'll have some other things done other than just the storing an initial value. All right, so we've seen constructors down here. Here's the one for rectangle. I'm bringing in two values, a length and a width. And we had a little trouble with this last week, making sure this guy, who's now a local variable, he's only temporary. But right now, he's holding that value coming in, and we want to assign it to our field. This is the name of a field in the rectangle class. We bring a value in W. We want to assign it to a field. Now, we're going to choose to always do different names. But at some point, we'll talk about, well, could I call this length just like this is length? And how does that work? Yeah, we'll talk about that. But for now, we used to have to do that kind of deal. But for now, we're going to say this is the value coming in. I'm using the assignment operator and assigning it to length. With constructors, we can actually play a little bit of a game and have more than one. This is a nice constructor. When I have more than one constructor, it's this thing called overloading. And overloading is when I have the same name, right? They're all going to be called rectangle, but a different parameter list. Okay. Sometimes this parameter list has a name called signature. And you'll hear me use that occasionally, especially when you move into 161 and some of the other courses in this class. All right, so I'm going to have more than one constructor. And I'm actually going from bottom up instead of top down. But here is one that we've seen and it was nice. Here's another one. What if I instantiate an object, call this constructor, and it only has one value coming in? Yeah, I see these are reversed. It only has one value coming in. Well, I could set length and side to that same value. So I could have a second constructor that has a different signature. Well, heck, I could have a third constructor that has no signature. This is what we originally used, and I mentioned last class, this is called the default constructor, where we call it, and I'm just giving it values. This will override the one that we don't see. Like there's a constructor in there so we don't need any constructors. And if I instantiate an object, it calls a default constructor that is somewhere else. That's another class. But this constructor, I can override because it already exists. I can do something overriding. And we get into overriding versus overloading. But overriding is saying, hey, replace that one that exists somewhere the default one, because I want to give initial values of 10 and 10. You notice there's no parameter list. This is called the user-defined default constructor. So here I have a program with 1, 2, 3 different constructors. And for those of you that read over 6.2, we are actually taking 6.1 and enhancing it. One of the enhancements is adding extra constructors to the program. Okay? Any questions on that? Any questions on overloading, having more than one constructor? They all have the same name, they have different signatures. So it knows which one to use. And again, we got this straight last week, how this works, because a couple of groups had the same kind of problem, but boom, there's the constructor. Any questions? Okay. Now I'm going to jump to this section 8.4. I'm going to pause the recording because I wanted to do something. Go. Okay. So say I created binga, 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 binga. Say I created, don't look at my notes up there yet. A rectangle R1 equals new rectangle. Oh, and I'm using the default constructor. There are no parameters in there. Now, you know that when I create this, R1 has a length, R2 has a width, and all of that. Well, what if I said to you this? I want you to print out R1. What if I said something, and this is for demonstration purposes only, system.out.println R1. What if I said do that? Or message dialog box, parentheses, null, R1. What would get displayed if I said, go do that object, print out that object? Well, this is done. Remember that place I said where the default constructors are? This is figured out up there as well. And this says, well, if I try to print this, it's not going to crash the program, but I'm going to get some kind of crazy output, some kind of hex code and something else. So it's not going to die, but it's going to give me some craziness. Well, this comes from something called a toString. And that toString is actually a method. And this toString is something that is innate for that I want to use now. So I'm now going to take, I got to stop saying, I'm going to take a look at Al Haji's demo. Well, that's not it. Stop sharing. And I want to share. Where is it? Here. Okay. I am specifically talking about these lines right here. And you notice how it creates a string, makes one nice big string. And this is perfect. It's great. I love it. Well, this is for df. This is for the object df. Well, what if I had another object called rj? I'd have to do all of this again. And what if I had another object called cf? I'd have to do all this again. Or an object called OM. I'd have to, well, what if I said, well, let's take this out of our demo and put it somewhere else so that I can reuse this block of code. Wait a minute. Reusing a block of code? That's our definition of a method. That's our definition of a method. So this guy is now going to be yanked out of here, and it's going to be put over in the class, and it's going to be put in there something called a toString. So all that stuff of Al-Haji's, I would copy and paste and put it right here. Like pretend this doesn't exist. This is, I would just copy that right. Al-Haji, you're halfway done or a quarter of the way done with the next program. Because I'm telling you, cut that and put it right in here. Now, what is a toString? Okay. It's the last method in the UML chart. It's going to be the last one down there. It has a name toString. We're actually replacing a different toString, the one that prints out all that garbage. We're making our own. Now, when I write the class toString, I'm going to use the verbiage toString. Its return type is a string, so I need to be returning a string. So Al-Haji's code would go here and we would be returning, let me find it, share, where are you? There you are. We would be returning output. So when I get ready to do, I'm going to make this my toString, put it somewhere else. So now when I come in here, I'm going to say, what is my object? DF. When I do this, it calls the toString method. That's the last. It'll do all of this. And we're going, what? I'm like, yeah, you're going, what? And we're all happy. Because I can reuse this over and over for any object name I want. It's a pretty cool method. The toString, right? We create a nice big string and then we just sort of print out the object. We would just be printing out R1, right? We don't need R1. Let me write this. We don't need R1.toString. We don't have to call the method. When I try to display R1, it automatically calls toString. It goes and it gets it. Gets it good. All right. Big number 2 today. The toString. It returns a string. It's whatever string I created. Bad to the bone. Okay, before we do the last 2 sections, shooby dooby doo, we've written a bunch of methods, right? And I'm writing a method here. It's called some method. And we've learned we can return a whole bunch of different things. And we've learned we can pass in a whole bunch of different things. Let's see. I could do a void. That was our special one, right? I can do a void. It's an ugly D. I could do an int. I could do a double. Give me another one. What else can I return?
Boolean,
Boolean and another.
float, I guess. No, float.
Could do a float. Yeah, that comes in the double family. Or we could return just a char if we wanted. We could return a string. That's what else we could return. Rectangle. We could have a return type that's a rectangle. That's like each one of these is a data type. Any data type that we learn about can be returned from a method. Some method, I don't know what it does, but I could return any one of these that I've learned about. And we're going to keep learning about data types, and we can just keep doing these public, static, yada yadas over and over and over. What can be in my parameter list? What can be empty? That's fine. We could have ints inside of here. We've done that. We've done doubles. I don't know if we've done any booleans, but that's possible. We could have chars, right? We had a data type followed by some variable name, N1. But data type could be any of these. We even did strings. And guess what else we can put for our data type here? Any class. Any class. Remember, rectangle was a class we created. With that class, when we create class, we have all these fields and methods. It's a new data type. So I could have rectangle up here if I wanted to. Again, in this parameter list, these are all data types. Is it data or data? Whenever I hear data, I think of the robot from that one Star Wars series. Data. All right. When an object is passed to an argument, the address is actually what's being passed, which is nice because then I can make changes if I want to. We're going to get more and more into that. Star Trek. Yeah. We're going to get more and more into this. This guy right here passes the address. Don't worry about it so much right now. Here we go. I have a class named die. So this is a data type. My die, whatever goes along with it, I don't know. This could be the number of sides and on and on and on. But here I am passing it in. I am passing in the address. The address. Well, there's two S's. And that address is going to go over here and land in D. Again, here's my data type. Die, die. Not telling you to die, it's a die, it's a dice. Again, these are always just our data types. What if I was, oh, we did talk about overloading. But again, we passed them in, we can also return them. What's being returned? So if I did this, public static die, um, method something something, maybe get die. If I did this is my return type, that means inside of here, I'm going to create a die D. I'm going to do a whole bunch of work with it, whatever that is, filling it with values and so on and so on. And the last thing I'm going to do is return D. What is D? The address. And that's what I said I'm returning. Returns the address. Cool beans? Cool beans? Oh, there was a time when we had a lot more time, but we'd spend a day and we would actually write this program. We're going to write a program. I have one somewhere. I just have to find it for us to work with today. But check out this UML chart. I don't even know where it is. Check out this UML chart. If I gave you this, could you create this class? The answer is yes. I have fields. Fields. All good. I have not one, same name, but two constructors. Constructors. I have a bunch of methods, my sets and my gets. My accessors are the gets, my mutators are the sets. And I have a bunch of other methods, and finally, I have the toString. The return, nothing's going in, the return type is a string. So we took a day one time and we come in and the user would pick, boom, do they go into battle? And if they go into battle, you know, they would fight somehow, possibly get beat up. If they won the battle, they would get money and possibly a weapon. The other choices go to a healer, and the healer would take some money and give you health back. And again, we had all kind of stuff going on here. You could go to the store and buy a weapon. You could display your character's information, and all of a sudden, with this layout, we have some idea. We could possibly create a game of some sort. UML chart is kind of nice to have that before I start. Yeah. Okay. So what are we going to do today? It's right here in front of me. And it's sloppy, but we are going to play the game of 50-50, and I am giving you the UML chart. You're going to ask the user to pick one or two. So the user picks one or two. Then the computer is going to pick one or two. Game itself is pretty easy. If it matches, you win. If it doesn't match, you lose. Okay. So let's come in. All I need to know is how much money I have. I have a constructor where I can get started or I can get started with money. So there's two different constructors. Set balance. Okay. Some of these are really easy. I'm bringing in money. Get balance. Hey, how much money do I have? Add to balance. Would you like to add money? Yes. How much? If they don't ask, otherwise add to balance 450, subtract. So this guy is going to be, they're going to come in and you're going to say, how much would you like to bet? I'd like to bet $5. Okay. If I win, I add it to balance. If I lose, I subtract it from balance. Now, bet is five, or I can bet the random. For the random, if I win, it just adds 450. But if I lose the random, it subtracts 550. Finally, a two string to print everything out. Questions? Now, there's lots of ways to do this. One is the wrong way, and that's just to try to type all this up at once. I would get them working hand in hand. I would create and do this much. Like for me, I would do this much and then the demo where I just instantiate an object or two. Then I would do my sets and gets. I would do that second. ToString, I do that third so I can start to display it, make sure it's good. Fourth, I would let the user pick the amount. If they win, you add it to the balance. If they lose, subtract it to the balance. Fifth, I'd monkey around with this guy. So if I was writing this, I'd be working on both of them at the same time. Do this much in the class, do the demo. Add this to the class, do the demo. Just like when you walk through rectangle, you did it one piece at a time. I would add the two string so I could display everything. Hey, welcome to the game. Here's how much money you have, blah, 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 blah. It's not going to be a lot in this one. And the add and subtract. How much would you like to bet? Okay. And worry about this guy last. Now, why is this guy in here? Because you notice I am overloading add balance. I am overloading subtract balance, sub balance, just like I have overloaded constructors. So it's a little bit of practice with a lot of everything.